Alright everybody, welcome back to chem class. Room doesn't look quite the same with all the stuff moved around, but I figured you were all missing it and I'd give you a quick look. Also, Bella's here. She says hi. Bork. So today I'm going to walk you through some acid-base stuff, and it won't be quite as extensive as it would be if we were all together, but that is okay. I would look through the notes and other resources that I have on Google Classroom, and I'm going to walk you through a few examples that will help you with the acids and bases calculations practice assignment that you will be getting. So, first example we'll do is if the pH of a solution is 9.0, what is the hydrogen ion concentration? And there will be a series of formulas that you'll use, and that's really simple. At the most difficult, it's just a little bit of algebra. So all you have to do is look at your problem, what is given to you, what is asked of you, and what equation would be most useful to you. So if you were given the pH and you are asked for hydrogen ion concentration, you will use the easy formula of hydrogen ion concentration is equal to the antilog of the negative pH. And if you are using a scientific calculator like this one, antilog is the 10 to the x, so hit second log and it will pop up for you. So second log, bam, there you go, negative 9.0 for our pH. And there you go. So that is how you'll work the calculator. And writing it in there, make sure you write everything out and show your work. So 10 raised to the negative 9 gives you 1 to the negative 9. And a quick thing about sig figs is that sig figs are kind of strange in that pH will have a decimal equal to the number of sig figs in the hydrogen ion concentration. So since we had 1 decimal point, our hydrogen ion concentration may only have 1 sig fig. I'm not going to hold you to that like very strictly, but if you were wondering, what about sig figs? Sig figs are never going anywhere. They've never really left us, not for long. You would be correct. Okay, so second example that we will do is if the hydrogen ion concentration is 4.2 times 10 to the negative 11 molar, what's the pH? And in order to solve for this one, all you have to do is take the negative log of your hydronium ion or hydrogen ion concentration. When we were talking about acids, it's the hydronium ion, the H3O plus, but most of the time we just write down hydrogen. So you take your negative log of your hydrogen ion concentration, and that gives you the pH of 10.38, which is alkaline or basic. So when you're looking at pH, anything below 7 would be considered acidic, anything above 7 is considered alkaline or basic, and 7 is neutral. So for the next problem, calculate the pOH if the hydroxide ion concentration is 6.4 times 10 to negative 1 molar, and also what is the pH. So two-parter. First part, we'll take the negative log of the hydroxide ion concentration to find our pOH, which mirrors the other formula that we were using. So negative log of 6.4 times 10 to the negative 1 gives us a pOH of 0.19. And pH plus pOH will be equal to 14.00 all the time. So if you have one of these, you can solve for the other, knowing that when they're added together, you get 14.00. So to find the pH, we will subtract our pOH from 14.00, and so the pH of this solution would be 13.81. Last quick example I'll do with you is what is the hydroxide ion concentration in an aqueous solution with a hydrogen ion concentration of 3.45 times 10 to the negative 2. And for that one, we will use a formula of Kw, which is the equilibrium constant expression for water. The ionization constant, we might talk more about this, but not in great extent because of the circumstances we find ourselves in. You'll have a very short equilibrium assignment here in the coming weeks, but for right now, all you need to know is that Kw is equal to the hydrogen ion concentration multiplied by the hydroxide ion concentration, and that will be equal to 1.0 times 10 to negative 14. So it's just algebra, basically. So we are given a hydrogen ion concentration of 3.45 times 10 to negative 2. Plug that in, divide on both sides by the hydrogen ion concentration value, and that will give you the hydroxide ion concentration value of 2.90 times 10 to negative 13. And that's it. So with these 4 sample problems, you will be able to do all 12 problems on your paper. A couple of quick things that I wanted to talk about very briefly is that in your assignment, all acids and bases will be strong. So if you are given the molarity, you can take that and use it as the hydrogen ion concentration if you're dealing with an acid, or the hydroxide ion concentration for a base, because strong acids and bases have 100% ionization. And here is a quick rundown of your formulas. pH plus POH equals 14.00. Hydrogen ion concentration is 10 raised to the negative pH. Hydroxide ion concentration is 10 raised to the negative POH. The antilogs, pH is equal to the negative log of the hydrogen ion concentration. POH is equal to the negative log of the hydroxide ion concentration. Equilibrium constant, hydrogen ion concentration multiplied by hydroxide ion concentration is equal to 1.0 times 10 to the 14. And rearranging that, you can solve for hydrogen ion concentration or hydroxide ion concentration, pH range, pH scale. And if you should happen to have a problem such as this, where you have a compound like a barium hydroxide, where you have a subscript 2 outside of your hydroxide ion, if you were to have a molarity of 0.45 molar, since you have that 2 subscript, you need to double that for the hydroxide ion concentration. So for this one, the hydroxide ion concentration would be equal to 0.90 because of that 2 subscript you have to multiply. So with this video and the rundown of the formulas that you will need and what has been posted on Google Classroom and notes and all that stuff, you should be in good shape to finish your 12 problems on acids and bases. If not, email me, get a hold of me. I will help you. Take care. I'll see you sometime.